So we've talked about personal attacks and emotional appeals. We now move on to discuss fallacies of weak induction. Our third video will focus on fallacies of unwarranted assumption or diversion. Remember, in each of these videos, the focus is on recognizing fallacies in ordinary language by way of a thorough analysis. On a daily basis, argue from what we observe, argue from what we have experienced in the past to the present to the future. We oftentimes will argue based on present experience to something that occurred in the past. You get the basic idea, right? That we use experiential reasoning with great frequency. But we can make mistakes. We're typically quite good at it, but we do make mistakes. And this list of fallacies involves specifically poor experiential reasoning. Our next fallacy is the fallacy of accident. And this fallacy occurs when a general rule is misapplied to a specific case. So what we want to do is first identify what the policy in question is, and then look at the case to which it's applied and determine how it is a misapplication of that rule or policy. A great example, I think, comes from a case in 2003 in which two teenagers were at a party, and one of them ended up being accused of and serving time for molestation. Now, the problem here is that the law used as the precedent applied in this case was a law intended for child molesters. In other words, it's a law that was not intended for teenagers who, let's assume, were acting consensually, albeit in underage sexual activity. So take a moment to read this example. Now, the opposite direction of inference is called the hasty generalization, and this occurs quite frequently in the form of stereotype making. So whenever you think that someone has made a stereotypical comment that is, let's say, offensive to a certain group, then it's probably the case that that person is using the generalization known as hasty generalization in order to commit that stereotypical thinking. So when we make a general claim based on an inadequate sample size, then we are engaged in hasty generalization. So here's some, I hope, pretty clear examples. The first few sentences of this novel by John Q. Ryder are boring. Therefore, all John Q. Ryder's novels are boring. Yeah, I've met a few Iraqis. They were rude. All those Middle Easterners must be barbarians. Americans are so boorish. I know this because I saw one talking loud on his cell phone in a Paris library. And then a real life example. When Mexico sends its people, they're not sending their best. They're sending people that have lots of problems, and they're bringing those problems with us. They're bringing drugs, they're bringing crime, they're bringing rapists, and I assume some are good people, end quote. The implication is still that the vast majority of Mexicans apparently are rapists and criminals, and Mexico is in fact sending these individuals to the United States. What we want to focus on here is the fact that Trump is arguing that there are very, very, very many Mexicans in the United States. Grammatically, he's suggesting that almost all of them are criminals. And I was talking to my neighbor about this when it happened, and he actually has family from Mexico, and he kept referring to his family as clearly criminals. And that was sort of the joke. All you need when you see someone, hear someone committing the hasty generalization fallacy is to provide a counterexample. So this line of reasoning does not bode well either in our daily lives or in the sciences where it can also occur. Now we move on to ways in which statistical reasoning can go wrong. An inference based on a biased sample is an inference that is an inference that's made from a sample that is not legitimately taken from the population and yet is used to infer something about an entire population. So before we get to how this reasoning fails, let's talk a little bit about statistical reasoning, what it's meant to do, and how it's meant to work. Statistics is the science of learning from data. It is essential to conducting effective research that involves data. Now, I'm leaving the word data undefined, but typically we're talking about anything that you can quantify, right? So typically the data that we're talking about is numerical data or data that you can measure in some numeric way. We live in a world that is increasingly driven by what data tells us. So think about how Amazon and other companies use data to make purchase suggestions for you, or how a company uses data to make business decisions, how scientists use it in medical studies. In fact, if you look at the way that colleges and universities are accredited, you'll find that a major component of this accreditation process is a look at the ways in which the institution does or does not reflect itself as a data-driven institution, so that decisions are based on or driven by what the data tells them. For example, completion rates for courses, completion rates for programs, completion rates for graduation, and so forth. When we're talking about the social sciences in particular, but certainly any scientific endeavor, and we're talking about samples and populations, we're talking about the following. Any group of objects, a subset of a population, a sample that accurately reflects the characteristics of the population, and a random sample, which is the sampling that is based on everyone in the population having an equal chance of getting chosen as a sample member. Now let's look at some examples where sampling is not representative or random. Tall people are smarter than short people. A recent study compared the mathematical skills of volleyball and basketball players with kindergartners, and this demonstrated the conclusion, namely that tall people are smarter than short people. Now, this is an obviously poor piece of reasoning, but it gives you a flavor of what we're talking about when we're talking about biased samples. The sample here is not representative, but instead is skewed to make tall people appear smarter than short people. Moreover, there is an assumption that math skills are good indicators of intelligence. So one thing to bear in mind when you're looking at news reports about this, that, or the other study that gives you a bunch of statistics is to bear in mind that the study is assumed to have been completed without any kind of bias sampling, but that doesn't mean that that has been successful. Another example, there's no doubt that U.S. citizens think Rihanna's new album is a work of artistic genius. An online poll of music fans shows that this is the case. So the sample is not representative. We don't know about all U.S. citizens because it is very likely the case that the only people who took the online poll are people who either love or loathe Rihanna's new album or Rihanna herself as a performer. In addition, unless there's some sort of control, we don't know how many times individuals. We next move on to one of the most important set of fallacies, which I'm going to just sort of put under the umbrella false cause. So when we have false cause reasoning, we have reasoning whereby someone infers an effect from an alleged cause or infers backward from an effect to an alleged cause, but the causal relationship is faulty or erroneous. A really simple way to think about this would be to say, I get up in the morning and as the sun rises, I see planes taking off from my local airport. Therefore, the sun causes planes to take off. When you respond to that, well, no, there's a better way to account for planes taking off, then you've probably identified some version of a false cause fallacy. Here are some examples. UFOs must be propelled by some sort of electromagnetic source. On the night of the big power blackout in New York City, there were a number of reports of UFO activity in the area. So there are a couple of problems here. One is that the blackout was caused by UFOs, and the other is that UFOs are propelled by an electromagnetic source such that they would cause this blackout. Remember, UFOs are unidentified flying objects. Second example, if you want more available clean water per capita, you need fewer people on Earth. If you want to decrease vehicle emissions, you need fewer drivers. If you want the oceans to replenish their fish, you need fewer people. In other words, the implicit causal reasoning here is that people are causing all of the problems that we have, therefore we should eliminate a number of people. Last example, if strong law enforcement really prevented crime, then those areas where community policing were in effect would be the least likely to have high crime rates. Actually, the reverse is the case. For in those areas with high concentrations of police, serious crimes of all kinds are more common than in other areas where police visibility is much lower. Here, the arguer misunderstands the order of causation. Here is an example from our favorite source of fallacies, one of two favorite sources, I should say, advertising, the other being politics.
You give a little love, and it all comes back to you. You're gonna be remembered for the things that you say and do. You give a little love, and it all comes back to you. You're gonna be remembered for the things that you say and do.
So the implication here is that drinking Coca-Cola makes the world a better place because drinking Coca-Cola has made a Grand Theft Auto criminal, or I guess a Grand Theft Auto-esque criminal, turn into a good guy who does good things, impacts people in a positive way, and they in turn do the same.
Very superstitious, writings on the wall. When you believe in things that you don't understand, and you suffer. Superstition ain't the way.
Now, if that that Bud Light commercial is not a quintessential false cause fallacy example, I don't know what is. Of course, this cartoon, another one by a cartoonist I think is quite funny, Beck, is also a good example. There's one duck on the right looking sad. The duck on the left says, maybe you should ask yourself why you're inviting all this duck hunting into your life right now. It's a play on what a lot of us might say to our friends when we find someone is, continuously choosing the wrong boyfriend or girlfriend, and we say, you keep attracting the same sort of person. Of course, the problem here with the poor duck is the duck's not doing anything wrong. The duck's just being a duck. It happens to be duck hunting season. That's what's causing all of this duck hunting. And I always claim that a good liberal arts education, yes, must include classic texts, literature from Shakespeare and Newton's Principia and all sorts of great stuff, right? But it also has to include Gary Larson. Gary Larson's The Far Side is one of the most awesome, funny, smart cartoon series that I know of. All right, so we have the following. One toad or frog says to the other, wait a minute, Vince, last summer, remember? Some little kid caught you, handled you, and tossed you back in the swamp. That's where you got him. It's a play on the old saw that warts are caused by handling toads. All right, another version of a false cause fallacy is known as the slippery slope. The slippery slope is typically just an extended false cause fallacy. Basically what happens is this. Someone argues, typically it's to the negative, don't do this thing, whatever it is, or don't believe that thus and such is the case. And the reasoning is, if you do this thing, if you believe this thing, it's going to yield disaster, so don't even start. In other words, once you take a step off that slope, you will slide down into the muck. So what you want to look for when you're thinking about slippery slope is that break in the causal chain. If voluntary euthanasia were to be legalized, it would prove impossible to avoid the legislation, or at least toleration, of non-voluntary euthanasia. But even if the former can be justified, the latter clearly cannot. Hence, it is better that the first step not be taken so as to prevent a slide into non-volunteer euthanasia. So the idea is that doing this one thing is going to lead to such a bad consequence that nobody would accept, because we would all be in the position of potentially being killed, and so we should not allow any form of euthanasia. So what you want to do when you're looking at this sort of reasoning is to see if you can find out where there might be a gap such that the alleged cause really does not bring about the purported bad effect. You get some good examples of this. They're funny, but you get this in some commercials. I'll show you a couple in just a moment. But take a read here and try out what I just mentioned. Take a read and find where you think the reasoning fails. Where is the first misstep? Where is the first moment where the alleged cause would not be explained well in terms of the effect? In other words, the effect is not likely from the purported cause.
When you have cable and can't find something good to watch, you get depressed. When you get depressed, you attend seminars. When you attend seminars, you feel like a winner. When you feel like a winner, you go to Vegas. When you go to Vegas, you lose everything. And when you lose everything, you sell your hair to a wig shop. Don't sell your hair to a wig shop.
All right, so we are going to turn next in our last video to fallacies of unwarranted assumption. But I hope that you have a good idea of what constitutes a fallacy of weak induction, that you're able not just to identify a particular error as this or that fallacy, but that you can actually articulate what's gone wrong and why it's problematic.